Hey guys, welcome back to Civil Learning Online, and today in this video I am going to discuss about relaxation method, which is topic from numerical analysis subject. And at the end of the video I have also provided a question for you guys, so watch the video till end and you will find it very helpful because I have explained each and every step very well. So without any further delay, let's get started. So I'm going to first pick out the equations which were provided in the numerical. First let us write down here solution, and the three equations are 8x plus y plus z equals to 8. Second one is 2x plus 4y plus z equals to 4, and the third one is x plus 3y plus 5z equals to 5. Now guys, whenever we are provided with the equation and we are asked to solve that using relaxation method, then you can notice one thing, that in each and every equation the coefficient of x will be greater in one equation. In second one we will find the coefficient of y greatest of other coefficients. Similarly, in third equation we will find the coefficient of z greater than any other equation. As you can see here, in first equation we have coefficient of x greater than all the coefficient of y and z comparatively. Similarly, in second equation we have this coefficient of y is greater than the coefficient of x and z. In third equation we have the coefficient of z greater than the coefficient of x and y. Now what we need to do is, in second step we will need to write the residual form of these equations which we are provided. So the residual dual form of given equations are, let us denote the residual form as r1 equals to. Now what we need to do is, we have to bring all these coefficients on another side of this equal to sign. So we will have here 8, and this positive 8x will be negative 8x, and positive y will be minus y. Similarly, positive z will be negative z. Again, r2 we will have 4 minus 2x minus 4y minus z. Similarly, r3 will be equals to 5 minus x minus 3y and minus 5z. And after this step we have second step, and in that step we will need a table for operation, which is very important, and we will frequently need that table while applying different approximations. So let us draw a table for operation. So here it is, table for operation, and the table for operation is given as, we will have 3 rows and 3 columns. So r1, r2 and r3. Similarly, and these are columns. And now time for row. So row will be del x, del y and del z. 3 rows and 3 columns. Now in r1 we will rewrite the coefficient of each and every terms. This is r1, this column represents r1, and this row these horizontal lines or boxes represents our row, and these are columns. So in r1 we have coefficient minus 8, minus 1, minus 1, and this is the column for r1. So we will have here minus 8, minus 1 and minus 1. Similarly, for r2 we have here minus 2, minus 4 and minus 1. Similarly, r3 we have minus 1, minus 3 and minus 5. I hope this is visible to you guys now. Now let's begin with our first approximation. And in first approximation we will begin with taking value of x equals to 0, y equals to 0 and z equals to 0. Now let us see how it is done. So first approximation. For first approximation we need to take x equals to 0, y equals to 0 and z equals to 0. Now guys, what we need to do is we have to put these values in the equation r1, r2, r3. So if we put x equals to 0 here, y equals to 0 here, and z equals to 0, then we will have r1 equals to 8. Now for r2, again put x equals to 0, y equals to 0, z equals to 0, then we will have r2 equals to 4. Similarly, we will have r3 equals to 5. Now after doing this step, oh sorry, it was not visible to you. Now you can see here, now we will check for the greatest of all these values among r1, r2, r3. As you can see here, we have r1 is greater or greatest of all, so we will write here one line, that is maximum is r1. What is the value? 8. So maximum is r1 and its value is 8. Now we need to find the value of del x, because in r1 the coefficient of x is greatest. In r1 coefficient of x is greatest, so we need to find del x. So for calculating del x, what we need to do is we have to divide this r1 by negative value of greatest value in this row, and in del x row, this is del x row and this is r1 column. So in del x row, maximum value is 8. In one condition, what we need to do is we have to take opposite sign. This is -8, so we need to write here +8, so +8. So divide this by +8. We need to change the sign also. If here it was +8, then we would have to take here -8. We would have to take here -8 if it were positive. So as it is negative, so we will take +8. So we will get the value of del x equals to 1. Now this is the step for first approximation. Now let us begin to move to second approximation. So here is second approximation. Approximation. And for second approximation, we will need this operation table and the value of r1, r2, r3 which we had got in first approximation. So I have copied it in an extra sheet. Now let's rewrite it here. We have r1, r2 and r3, and which is 8, 4, 5. This value we got in first approximation of r1, r2, r3. Now simply write the minus sign here. Now after this, what we need to do is, as in first approximation we got del x value, so we will move for del x in second approximation. So, and while moving on for del x in second approximation, what we need to do is we have to take the opposite sign of each and every elements. That is, here we have -8, so we will write here 8. This is -2, so 2 times, and here it is -1, so 1, and this whole is going to multiply with the value of del x, so 1, 1 and 1. Now on solving this, we will get the value of new r1, r2, r3. So we will get here 8 minus 8 will be 0, 4 minus 2 will be 2, and 5 minus 1 will be equals to 4. Now among all these three values, we have greatest value 4, and this is for r3. And in r3 we have del z0. In r3 we have del z0. So what we need to do is we have to divide this 4 by the value of del z, and this time we do not need to change the so again while dividing we will need to divide with the opposite sign. Here we have -5, so we will divide that value with +5. So we will have here, write a line here, maximum value is maximum is r3 equals to 4, and in r3 we have del z, so del z equals to 4 divided by we have in del z we have -5, so divide this by 5, then we will get here 0.8. This is the value of del z. Now let's move to third approximation. I hope you are understanding these steps. And now for third approximation, again the steps are similar, so write it here, third approximation. And for third approximation, again we will rewrite r1, r2, r3, and the values changes here. This time r1, r2, r3 will be these three values, so 0, 2, 4, minus minus minus. Now we have del z, so we need to we will subtract this value at the end, but for that, before that, in del z we have minus 1 and minus 5. So change the sign, so we will have here 1 1 5. I hope you are understanding. Here we have del z, so and here it is r1, so we have taken the value of r1, r2, r3, which we got from second approximation in third approximation. Now after that, what we need to do is we have to subtract del z, and del z, coefficient of del z are 1 1 and 5, so 1 1 and 5, and we have got the value of del z in second approximation as 0.8, so multiply this by 0.8 0.8 and again 0.8. On solving this, we will get minus 0.8, and again we will get here 1.2 and 0. Now what we need to do is we have to again look for the maximum value, and maximum value is 1.2 here, so we will write here maximum is r2, so r2 equals to 1.2. Now we will get the value of, in r2 we have del y greater, in r2 we have del y greater, so minus 4. So we need to divide this by del y equals to 4 divided by 1.2. You may have a confusion that how minus 4 becomes greater than minus 3. How minus 4 becomes greater than minus 3? Because this time we are considering the opposite sign. Here all are negative, so we need to consider all these coefficients as positive. So 1, 4 and 3, and among 1, 4 and 3, 4 is greater, so we need to divide this by this value, sorry, I have mistaken here, 1.2 is divided by 4. So on doing so, we will get del y equals to 0.3. Now let us move toward fourth approximation, and again the step is going to be same. We need to copy the value of r1, r2, r3 of third approximation for the fourth approximation. So we have fourth approximation, we have r1, r2 and r3 equals to minus 0.8, 1.2 and 0, and again we need to subtract this, and for r1, r2, r3, and we have got del y. So in del y is this horizontal raw, so 1, 4 and 3, so 1, 4 and 3, we need to take it of opposite sign, so multiply this by 0.3. what we have got the value of del y in third approximation, so 0.3, 0.3. Now on solving this, we will get some values, and they are minus 1.10 and minus 0.9. Now in again we need to look for the greatest value among all these three numbers, and the greatest is going to be again once again here 1.1, because both are negative, and we will need to consider without considering this negative sign. So if we cover this negative sign, now we can see that the 1.1 is greater than 0.9, so we will have here del x, so the maximum value will be minus 1.1, and we need to divide this by the greatest value of del x. So we will have here maximum is r1 equals to minus 1.1, and divide this by this is del x, so divide this by 8. In del x column we have the greatest value 8, so and we need to take it as positive, so divide this by 8, and we will get here minus 0.1375. Sorry, here it is 1.1. I am going to rewrite the second step here. So we have del x greater, so del x will be equals to minus 1.1 divided by 8, so we will get here minus 0.1375. 0.75. And now after getting the value of del x, what we need to do is we have to move toward the fifth approximation. And once again I am going to tell you same thing, that we, while considering the greatest values, just simply cover the sign and look for the numbers only. So while looking for the numbers only, we will again have this condition in one more approximation. Then again that is going to be more clear to you guys, but here it is necessary. So 1.1 is greater than 0.9, so we need to divide this 1.1 minus 1.1 by the greatest value of in del x, that was 8. So 8, and we got minus 0.1375. Now move for the fifth approximation. So we have fifth approximation. So in fifth approximation we will again rewrite it as R1, R2 and R3, and copy the value, that is minus 1.10 and minus 0.9. Put the minus sign, and after putting the minus sign we need to check for the table again. We have calculated the value of del x, and in del x column we have minus 8, minus 2 and minus 1. So 8, 2 and 1. We will have here 8, 2, 1, and multiply this with the value which we have calculated in the fourth approximation, that was minus 0.1375, and try taking up to 4 decimal places, means up to 4 numbers after decimal. So we will have here minus 0.1375, minus 0.1375, and on solving this we will get the value in the fifth approximation as 0.275, and again we will get here minus 0.7625. Now guys, after this what we need to do is we have to check for the greatest value again among these three numbers. Again neglect the sign here, positive negative sign, do not consider, just look for the number. Among these three numbers we have this 0.7625 as greatest, so we will have here maximum is R3 equals to minus 0.7625. Now as R3 is greater, in R3 we have greatest value as del z, so we need to calculate del z. So del z will be equals to minus 0.7625, and the greatest value in the del z row was 5, so divide this by 5, and we get the value as minus 0.1525. Now it was the step what things which we were needed to do in fifth approximation. Now let's move for the sixth approximation. Steps are same, just follow the steps and solve your numerical. So here comes sixth approximation. We simply need to copy the value of R1, R2, R3 of the fifth approximation and put the minus sign here, and now look for the in fifth approximation we had calculated del z, and in del z we have the greatest value 5, so we need to divide and we have the greatest value 5, and in del z we have 1, 1 and 5, so 1, 1 and 5, and multiply the value which we had got of the value of del z in fifth approximation. I have written is as it is, and solving each and every we will get these values. Similarly we need to calculate the maximum value of 4, and among these three value we have the greatest value this R2, and in R2 we have the greatest value 4 here in operation table, and that is 4, so divide this value by 4, and on dividing we will get to 0.1069, and that is the end of sixth approximation. Now for seventh approximation what we need to do is we have to copy the value of R1, R2, R3 which we have got in the sixth approximation, which are as it is here. Now for seventh approximation we need to calculate, as we have calculated del y in sixth approximation. So in del y we have greatest value, we have the values of R1, R2 and R3 as 1, 4, 3. So 1, 4, 3, just changing the sign, positive to negative, negative to positive, and multiply that with the value which we have calculated previously in sixth approximation. So it is as it is. On solving this we will get this much. Now among these three numbers excluding the negative sign, we have greatest value as 0.3207, which is greater than 0.00456. So we have maximum is R3 and minus 0.3207, and divide this by the greatest value in R3. So in R3 we have greatest value 5, so we have divided this by 5 with an opposite sign. Here we have minus 5, so we will divide this by positive 5, and on dividing we will get this value. Okay, sorry, it was not visible to divide this by 5, and we will get this value. Now move for the 8th approximation. And for 8th approximation, just copy the value of R1, R2, R3 of 7th approximation. Here it is. Now we need to subtract, so minus sign, and in 7th approximation we have calculated del z, and in del z the coefficients of R1, R2, R3 are 1, and 5, excluding the changing the sign. So 1, 1 and 5, and multiply this with the value of del z of 7th approximation, which is as it is. Now on solving this we will get this value. Now among these three values, the maximum value is 0.1097. So maximum is 1097, which is our in R1 we have greatest value as del x minus 8. So divide this by 8, and this is our R1. And now on dividing this we will get this value. And now move time for the 9th approximation. So in 9th approximation again we will simply copy the value of R1, R2, R3 of 8th approximation, copied. Now minus sign, and in 8th approximation we calculated del x. So among del x the values are 8, 2 and 1. So 8, 2 and 1, and multiply this by the value of del x, that is 0.0137 in each and every terms. So on solving this we will get this value, and again we will look for the maximum value among all these three, R1 and R2 and R3. So the greatest is 0.0367, which is greater than minus 0.0137. So I have written as it is. Now divide this with the greatest value among del y. So in del y we have greatest value as 4, so divide this by 4, and on doing so we will get 0.00917, and we have to take up to 4 decimal place. So we need to round off this one, as it 7 is greater than 5. Up to 5 we have to increase the preceding number by 1. Whenever a number is followed by 5 or more than 5 number, then we have to increase the preceding number by 1 for doing round off. So 7 is greater than 5, so we need to write this 1 as 2. So we will have here 0.0092, and that is the value of del y in 9th approximation. Now time for 10th approximation. So here comes 10th approximation, and in 10th approximation again we have copied the value of R1, R2, R3, which we calculated in 9th approximation. So here it is minus sign, and the value which lies in 10th approximation we calculated del z. So the we will write all the value of in the del z. Sorry, in 9th approximation we calculated del y. So we will write the values or the coefficient of del y, that is 143. So 143, and the value of del y was 0.0092. So on solving this we will get this value. Now copy this among these three values. We have the greatest value as 0.0413. So here it is greatest, maximum is R3, that is 0.0413, and in R3 column the greatest is 5. So we need to divide this by 5, and that is del z. So we'll get del z equals to 0.041 minus 0.0413 divided by 5, and we will get this value. Now we need to copy this value here in 11th approximation. So I have copied minus sign, and in 11th approximation what we need to do is we have to look the previous value, that is del z. We had calculated del z, and in del z we have coefficients 115. So multiply this with the opposite sign 115, and on putting this value we need to rewrite this del z value, that is as it is. Now solve this and look for the maximum among all these three values. So in these three values we have greatest value as 0.0083. So here it is, maximum is R2, 0.0083. We again do not need to consider this signs, negative or positive sign. We just need to look for the number. So here it is. Now in R2 we have greatest del y, so del y 1 4 3. So multiply this. We will do that in the later step, but for del y maximum is 4, so divide this by 4 and we will get the value. Similarly, in the 12th approximation we need to simply copy this value of R1 R2 R3 and again minus sign. And in 11th approximation we calculated del y, and in del y we had greatest value 4 and the numbers are 1 4 and 3, so we need to rewrite is 1 4 3 and multiply this with value of del y 0.0021, so as it is, and on solving this we will get this value. Again we will look for the maximum value among all these three, so maximum value is 0.0061. Here we have only three terms, nothing means 0, so 0.0030 and 0.0061. Greatest value is this, so here it is, maximum is R3, and in R3 we have del z greater, so for calculating del z we need to divide this by 5, so we will get this del z value. Now for 13th approximation what we need to do is, for 13th approximation just copy the value of R1 R2 R3, here it is minus sign, and in del z the greatest value was 5, so and the raw is 115, so 115 and del z value is this, and on solving this we will get this value. And again we will do solve for the maximum value, and the maximum is R1, that is 0.0017. again we do not need to consider the sign ahead of in front of these numbers, so here it is 0. This is greater among 0.0017 is greater than 0.0012, so greatest is this, and R1 is del x. In R1 del x is greater and the greatest value of del x is 8, so divide this by 8 and we will get this value 0.0002, which is near about 0. It means that is the end of this step. Now we will move to the final step to calculate the value of x, y and z using this relaxation method. So that is the final step, and we will need to draw a table at the end, so we will do those things here. So for finding the value of x, y and z, which will be equal to summation del x, summation del y and summation del z, how we can do this here? As I have calculated these values, so in the first approximation we have got calculated del x, so here it is del x is 1, so right here 1, and in second approximation we have calculated del z as 0.8, so right here in del z we will write here 0.8. Similarly in third approximation we calculated 0.3 which is del y, so here we will write 0.3. Now in fourth approximation we calculated del x as minus 0.1375, so minus 0.1375 and so on. Again we have del z equals to minus 0.1525, so in del z we will write here minus 0.15 and 25. Similarly, so these are the values which we get by relaxation method of x, y and z. Now I will provide you with the relaxation table, and which will clarify all the steps, which will be just the simplest form of writing the things which we have calculated throughout these steps. So I am going to draw a table here, that is simplest relaxation table. Here is the relaxation table which depicts all the things, all the values which we calculated in this numerical from up until approximation 13, and the value of x, y and z which we have calculated previously. Now you simply need to pause the video and copy all the values and of the which I have written in this table, now up to 8, and here 9, 10, 11, 12, 13 and the total value of x, y and z. Now time for homework for you guys, and I'm going to write a question here which you have to solve using this relaxation method, and the question is solve 9x minus 2y plus z equals to 50 and x plus 5y minus 3z equals to 18 and minus 2x plus 2y plus 7z equals to 19. Now solve this using the relaxation method, and if you want the solution of this numerical, then I will provide the link in description. First of all, you need to try it by yourself, and see you in the next video. Till then, stay safe and take care of yourself, and do not forget to subscribe Civil Learning Online.